Hello once again from Skip, Victor Echo 6 Bravo, Golf Tango. Well, believe it or not, I'm still playing with this old Teletype gear. I don't know, there's something about it that just appeals to me. I guess it's maybe the electrical over mechanical application of it all, I'm not sure, but I sure do enjoy it. In the previous video, I was showing everybody how I got this old demodulator up and running after 20 to 30 years, and then this old UART circuit. And just amazed me that it all came together and actually ran. I wanted to get all this put together and place it in a rack somewhere so I could have it, running whenever I wanted to show it off. And I had this nice hole in the rack for it to fit, but the two components together just weren't going to fit. It just wasn't big enough. The other problem might creep up on me if I ever get this Teletype stuff transmitting on HF is the piece of equipment right below it is my 3-500 amplifier. And you can just imagine the RF radiating off this tank circuit getting into the UART circuit of the Teletype. So a new chassis had to be made. So with that decision made, I headed back out in the shop and found some old scrap metal and aluminum and started hammering and bending once again. First thing I did was figure out what size of a faceplate I was going to need to fit in that hole that was in the rack that all this is going to go into eventually. Well, the big hole in the center is, of course, for the small CRT tube that fit into for the tuning indicator. And it was machined out, and then I just worked it with a sandpaper wheel to make it all fit. I also got fancy and made a nice mounting bezel for the front panel. Tapped holes into the faceplate for this bezel to fit to. This is a picture of the small CRT that fits behind the panel and fits up flush against the bezel. I worked on it to make it fit snug. Next I took the panel back into the shack and figured out where all the switches, the LEDs, the knobs for all the controls for the scope, rack handles, and so on were all going to fit, and got them all marked and drilled out the holes where they were needed. So the front panel all figured out and the size I needed. Next was the chassis. I found this lovely piece of aluminum I picked up, years ago, and it was just the right size. Even had flanges on one side that I could use. So once I got it all marked where I needed to bend things, once again, this metal is too thick just to bend, and it won't fit on my brakes, so back to the mill to notch in some grooves. This chunk of aluminum is kind of large, so I had to move it around quite a bit on the mill to get all the grooves slotted in where I needed them. It was a slow process, but it sure makes it easy to get a nice right angle bend where you want it. As I said, it took a lot of repositioning of the aluminum plate to get all the lines slotted where I needed them. I mill about halfway through it, and use a little bit of WD-40 to help the mill end to cut through it. And it seems to work. So this is what it looks like when it's all done and ready to bend. And like I said, it's too big for my little brakes, so you got to get inventive. The corner tabs or small edges were easy to do. I just crammed them in some metal bar I had, put them in a vise, and bent it over. That was the easy part. Is doing the larger pieces on the ends for the sides that got tough. Fortunate enough to have another big vise that's just laying on the floor. I use mostly as a clamp, and found some appropriate sized angle iron and got it situated in this way to do the big bend. Nothing to it. It bends down nice and easy, and I just kept warping it until I got a nice right angle bend at the corners, and that's all there is. After getting the main body of the chassis bent up and straight, I got the faceplate lined up and drilled holes and got it mounted to the inside flanges. Since this thing is going to be sitting on top of the HF amplifier, and I was kind of concerned about RF getting into the UART circuitry of the Teletype converter here, I had some new aluminum thin plate here that I bent into a lid and got it to fit nicely snug on top of the new chassis I just built. So with most of the metal bashing all done, the fun part begins. I drug the chassis back into the shack. Like I said, this is the best part of the whole project is assembling it all. In these pictures you can see where I've mounted some of the AC transformers, the sockets for the different circuit boards, and a D-rail for the various relays I hope to be putting into it eventually. You can see the socket for the CRT in the middle, and then all the different controls and switches and stuff for the front panel were put in next. Now finally, some of the wiring. You can see the various voltage regulators strapped to the bottom of the chassis, and some of the wiring heading all over the place. So the assembling and wiring continued. The various circuit boards for the demodulator, the UART circuit, the CRT deflection amplifier, all on those ugly perforated boards were slid in, and wiring continued. Finally, it was time to plug it in and fire it up and check the various voltages and stick a signal into it and see how it ran. At this point, it was so far so good, but my luck was about to change. So you'd think at my age I would be old enough to learn by now to never assume. But good old Murphy bit me again. So this is the setup here. I was testing the new demodulator chassis with the UART circuit. Hooked up to the Model 28 and receiving the news feed off the internet. So far so good. Everything was working just fine. These various news feeds and other sources off the internet are a great test source. Boy, it sure beats trying to get it off HF. Anyways, this is at 170 hertz shift at 60 words a minute. The old UART circuit is working well, shifting it up to 100 words a minute for the Model 28, and everything is good. So I guess it's on to the next part of the development of the new circuitry here. So this is the next part of the project, getting this paper tape perforator tied into the circuit. What's really cool about this old machine is that it punches out a 5-level tape of what you're receiving, or you can make yourself a brag tape and use it as a loop playback, or just as recording. It's kind of an old-fashioned way of doing things. Just another neat mechanical over electrical part of the system I like a lot. What's really good about this machine is it has a manual transmission for the 3 basic speeds of Teletype signaling. You can see there it's either 60, 100, or 75 words per minute. Using the UART speed shift or gear shifting circuitry in the demodulator circuit, this manual transmission was going to be handy to use. Depending on where I was getting the signal from, I might have to switch it from 60 to 100 words a minute, depending on how it's hooked up and what I'm receiving. This is a very simple or basic diagram of how this Teletype system works. The Model 28, represented on the right-hand side in the gray box, is mechanically geared for 100 words per minute only. I can't change that. So whatever's coming into the modulator on the left, the UART circuit speeds it up and keys it at 100 words per minute data over to the Teletype. So luckily for me, this newer perforating machine with manual transmission can be geared up or shifted up to 100 words per minute. So in other words, I can put the thing in series with the Model 28 Teletype on the data line. So when I was given this perforating machine, I don't know how many years ago, it came and had this wire hanging out of the end of it. And what I know of teletypes, I mean, what else could it be? It had to be the 60 milliamp loop wires for the magnet solenoids. So I assumed. So I was getting pretty excited, and I should have told me something right there. Anyways, this is the old perforator machine with the cover taken right off, and with the so-called 60 milliamp loop wire coming off from the back of it over to the demodulator chassis. The Model 28 wiring is on the terminal to the left, and the terminal to the right is what I had hooked inside. I had everything hooked in series, so just be wired up that way, and with a voltmeter to monitor the loop current. So everything was all hooked up and ready. I had the Model 28 running. The demodulator chassis was powered up. I reached around to turn on the AC switch of the Perforator machine, and this is what happened. Well, it wasn't quite that bad, but there was a terrific flash of bright light coming from the corner of the chassis, and then quite a plume of gray smoke rising out of it. So it gets the message across, the nuclear explosion. All the red circles on the circuit boards were blown, plus a few other transistors to boot. And a little higher up in the middle of the chassis, the 5 volt and the negative 12 volt regulator was blowing out of her. So, in other words, the whole UART circuit was shot, completely blown up. Anything tied to the 5 volt rail was gone. It was just toast everywhere. Amazingly enough, the demodulator on the lower left, circled in green, was still running, because it was tied on a 12 volt rail and completely independent of the 5 volt circuit. It was still shown at a mark in space pattern on the CRT scope. The Teletype had shut down because its auto start is derived out of the UART board, so there was no more typing. So I was dead in the water. Oh sure, I laugh about it now, but at the time I was pretty ticked off and quite sick to my stomach. Like, what the devil happened? What did I say earlier about assuming? Never assume. It turns out that the 60 milliamp loop wires, which I thought were the loop wires, were actually tied across the 110 volt AC circuit coming into it. Actually, the circuit that turns on the lamp that indicates that you're running out of paper ribbon tape. I talked to my friend who owned this machine before, and no names mentioned, but he has no idea what this wire was doing on there, and it's such a long time ago, neither of us have a clue, but anyways, I blew it. Like I say, never assume. So essentially what happened is 110 volts AC was fed into the UART circuit, flashed over to the 5 volt line, and blew everything up. So thus the bright flash and the smoke mushroom cloud. A little later on, I downloaded the service manual for this machine and found out that the proper loop connections are in this Amphenol connector just above the terminal strip where that AC wiring mess evolved. Anyways, we found out why. Getting another main UART chip was a challenge. Luckily, I found some on eBay. It was going to take 2 to 3 weeks, almost 4 weeks to get the darn thing, so I rebuilt a bunch of other parts on the circuit and slowly put it back together. I kind of intended to replace those ugly perf boards that I made the circuits on originally. Didn't quite want to go to this extreme, but now's a good time as any, I guess. Had no other excuse. So I designed a couple of positive layouts for the new circuits. In this picture you see them being exposed under the UV light. And then it was passed through the developer and back over to the etching tank to eat the excess copper away. This was a long process as my chemicals were getting weak, so I'm not showing the whole darn thing here. It just takes too long. So this is a couple of pictures of the UART board as it was in its good shape before it blew up, the top and bottom of it. This is what the new circuit board looks like. Much better than the ugly old perforated thing. Still had to run a few jumpers, but for my amateur status, it's good enough. So I went through various testing, getting the boards up to snuff and working as best I could. Got the new chips in from eBay and got her put together again, back into the chassis, ready for testing. Sounds kind of familiar, doesn't it? So a few weeks have gone by since I let all the smoke out of the circuit boards. I've been fairly busy outside working on the house, and other things while the summer's here. But I have gotten somewhere with this thing. I've able to get the Perforator working and the transmit distributor hooked up, and a few other ideas. That thing has progressed along and evolved into a little more complex machine. Remember this simple block diagram I used earlier? Well, throw this out because it's a lot more complicated now. One of the main things I did was, instead of trying to share the same high voltage power supply for the current loop, I decided to have a power supply in each individual unit. So the Model 28 has one, the Reperf unit has one, and so does the transmit distributor have one. It's a simple circuit, just a isolation transformer with a full wave bridge, capacitor, filtering, and then a current limiting resistor for the current loop itself. The voltage coming out of the current limiting resistor goes up into the amphenol plug, which is what goes to the solenoid magnets of the unit, then out again to the spare pair of terminals on the infamous terminal strip. This is a picture of the transmit distributor unit, or TD unit, I call it. It's the device that plays back the perforated ribbon paper tape. It also has a built-in power supply now. This makes it a lot easier, especially because this little unit here is geared for 60 words a minute only. It can't change. So getting things switched around in a UART circuit, makes things a little easier that way. This is a schematic of the interconnection between all the boards and the CRT monitoring scope itself. There is some signal flow paths there indicated, but this is a little too complex. Hell, I can barely follow it at times, so there's a better way of doing this. I've been going on about UART this and UART that, so I thought I'd quickly throw in a schematic here of what the UART circuit looks like. It's a fairly large chip, and you can see where the data comes in on the left through an optic isolator and goes into pin 20. There's two frequency input, two clock inputs on D on the left, or pin D, or pin 17, and H is the transmit clock output, or the transmit clock in, I should say, for the transmit output, which is on pin 40. The big UART chip is simply a serial in and serial out. It buffers it in the middle, and depending on the frequency going in on the clock in and the frequency going in the transmit clock in, determines what baud rate is going to be going. It's going to detect at, and what baud rate it's going to shoot it out at. So depending on the frequency going, I can go in at 60 words a minute, and then have the output at 100 words a minute. The circuit below it is what they call the auto start. It determines if it detects a legitimate teletype signal, it will close a relay and start the motor on the Model 28 teletype, thus auto start. There is a jumper selection called all print or select print. Select print means if it detects the proper start and stop signal in the serial data, then it will feed that data forward and out the transmit line. Otherwise, it will dump it. So it kind of filters out hash and garbage. The circuits on the far right, there's an RTTY brown plug. That's the output circuit for the Model 28 teletype. Then below it is the Reperf blue plug, and that's the output for the Perforator. So they're separate keying circuits for the two separate high voltage power supply units, or current loops. This is the simple clock frequency generators for the speed selection. It's an old-fashioned way of doing things with the 556 oscillators. Two oscillators in each chip, so it gives me 4 selections or 4 different speeds. The outputs are shown at the bottom there, and that's what gets fed into the UART chip through a multi-position select switch. Okay then, I've been going on here just a bit too long. Things are getting a little boring. So I'm going to show you how all this works in 3 modes. So hang in there and bear with me. So this is a simple, I hope simple block diagram of the whole operation of this circuit. Our signal flow is from the audio source going into the demodulator, indicated by green arrows. And you can see where it comes out of the demodulator, it goes through a few relays, and then finally through the optic isolator into the UART circuit. It comes out of the UART circuit, sped up now to 100 words a minute, which goes up to the Model 28 Teletype printer, and if I want it to be, it can also go out to the second output to the reperf unit to record what I'm receiving. So this is what you've seen before. It's the modulator taking in the audio tones off the newsfeed, off the internet. I got everything in standby mode right now, and you can see the mark and space signals on the scope. So the signal's coming out of the demodulator now, and I've got a scope hooked up to the output of the optic isolator, or the other words, the input to the UART circuit, and we'll have a look at that. So you can sort of see on the scope here, it's your standard TTL serial data, roughly just a little over 4 volts peak to peak, and chugging right along, and as you can hear in the background. So next I've got the scope hooked up to the output of the UART circuit, or right on the output of the switching transistor on the blue plug. This is the switching current loop that goes to the Model 28 Teletype, and see some interesting things here. We're on the high voltage current loop now, so you can see the main signal is right around 150 volts DC. There's some pretty large spikes though at the beginning of it, right up to almost 300 volts. Then of course the current loop signal is set over to the 28 and typing away the good old fake news or whatever else is on there about soybeans or something. The signal off the internet is a great source for testing this equipment, because you never find data going this long off the HF bands. Okay, next is the Perforator unit. I've got the covers off it so you can see the mechanism working. It's fascinating. So I've just turned on the main AC power switch, and the motor started up, and it's in standby mode right now, so the current loop is locked solid and the magnets are holding everything in place. I'll swing over now and we'll flip it into operate mode. It sure is a noisy contraption. Anyways, this now is, we'll say, recording the same signal or data that is being printed on the Model 28 Teletype right now. And it's being punched out on that ribbon tape. I can take this tape now and play it back here a little later on, and have a permanent recording of what I'm listening to or what I'm watching. The main thing I have to remember, and we'll say this mode 1, is I have to have the manual gear shifter in this reperf unit at 100 words a minute. And it'll just punch right along as we swing over to the Model 28 Teletype, and it's typing away at the same time. My standby switch on the modulator circuit or chassis here is kind of a 3-way function. If I push it down, I'll put the Perforator in standby mode. Or the switch in that position, you hear the Perforator machine is locked up in standby mode. I'll take the standby switch now and switch it into the middle position, which is full operation, so both machines are running again. And then I'll flip it right up to the top, and that puts everything in standby mode. You can hear the Model 28 motor shutting down from the auto start circuit, shutting it off. And then I reach around back and flip off the switch to the reperf unit. It took some fancy relay logic to get all this working correctly. So previously we showed how we could punch paper tape to a perforator with the signal coming in. But now I want to be able to make my own brag tape on the paper perforator. So it gets a little trickier. The main gimmick to this operation is reversing the input and output with respect to the Model 28 Teletype. The Model 28 is still geared for 100 words a minute. That doesn't change. So now we have to switch the input to the UART circuit to accept a 100 word per minute signal. And then the output, we wanted to spit out a 60 words per minute. So the two clock generators going into the input and the output of the UART have to be reversed also. This reversal is done by a toggle switch that's right on the console of the 28 Teletype. As you can see in the schematic here, it reverses relay 2A and 2B. It also activates relay 3, which puts the demodulator in standby and Actually changes the signal over to the TD unit, but we're not using that right at the moment. Okay, here we go once more. The unit is copying the news feed off the internet, and you can hear the Model 28 is hammering away over on the side. Please ignore my stupid camera trying to focus. It has absolutely nothing to do with the teletype. So we're done printing the news feed here, and we'll get on to what we want to do. So go back over to the main demodulator chassis and put the whole system into full standby. The demodulator is still putting out a signal because of the teletype tones going into it, but the auto start is shutting down the 28 because we're in full standby. So the first thing I have to do is remember to shift the manual transmission in the reperf machine over to 60 words per minute, that being the standard amateur basic or standard operation. The UART would do either way, 100 in, 60 out, or 100 out. It really doesn't matter, but 60 is the standard. Next, over to the Model 28 teletype. Since the auto start circuit has shut the motor off, I need to manually turn the machine on to get the motor running and the signal current loop up in operation again. Now, in order to get the 28 signal going into the input of the UART, I have to flip this toggle switch, which is what reverses everything. So the Model 28 is ready to go, so now back over the reperf machine and find the AC switch on the back side and power it up. I'll rotate this knob and advance the tape a little ways so I can rip it off to make sure I start anew, I guess you'd say. What a contraption this thing is. I just love it. Okay, I think we're about ready to test this thing, so here we go. Now with my two-fingered peck mode of typing, start sending some data out to the reperf machine. Start with a line of RY, kind of a universal test signal. These old machines, you got to remember to hit the carriage return line feed when you get to the end of the page, or it'll just be one black mark. It's sort of like my CW. It's slow, but it's sure. And then, of course, at the same time, the reperf machine is plunking out the tape. I didn't send too much of the message, but like I said, my CW is slow and sure, so is my typing. Well, that's sort of what it was punching out, I guess. So I was done sending the test message to the Perforator, so I threw the switch on the Model 28 Teletype to put the unit back into, we'll call it standard mode, mode 1. So in this normal mode, it's ready to receive standard Teletype signals once again. So this is what's on the paper and the Teletype of what I sent. Starting with ROI lines and then finally to my testing reperf unit statement. Then back to ROIs again. We'll play the perf tape back next. Okay, this is mode 3, or how I play the perforated ribbon paper tape from back to the transmitter distributor unit or the TD unit and over to the Model 28 Teletype. So looking at this block diagram, you can see the standby switch in the front panel is closed. And it puts the modulator in standby and throws our relay 1 over to the TD unit to play the signal back. The UART speed control is in its, we'll call standard configuration. The signal going into is 60 words per minute, and it steps it up to 100 words per minute to go back over to the Model 28 for printing. Also, it's showing where the signal path is on the output of the optic isolator, or the input to the UART circuit. There's another path that goes out there, and that is where it would be fed to the radio transmitter for going out in air, say for a brag tape or just a general message or whatever. It's at this point it's at 60 words a minute. So here we go, one more time to demonstrate mode 3. Just as before, the unit is printing out the news feed onto the 28, and I reach over and flip it into full standby. And like I said before, the demodulator is still receiving the signal, but the auto start circuit shuts down the Teletype motors. So now we'll get the punch tape we made earlier and get it installed into the transmit distributor unit itself for playback. It's a little tricky, but it's not too difficult. Getting the little, I call them track holes, lined up with a small sprocket that pulls the ribbon tape along is a little tricky, but once you get it in there, it's a free running position. You can kind of slide the tape back and forth to get it in position. So turn the power switch on, we're ready to go. Take my finger and get the function switch in the right position, not free, but in the run position, and it'll start up. You can hear the auto start circuit, just a slight delay after this one starts, that the Model 28 printer fires up. This demonstrates what I mean by brag tape. You saw how slow it took me to type this, and look how fast it's sending it out. So if you wanted to make a CQ tape or something like that, put it in the machine, let it transmit like this, and look like a professional. And that's all there is. It kind of goes into a idling position, and then the auto start shuts off the motors to the machine, to the Teletype itself. So that just about wraps it up for this version of my Teletype fun. Got a few more things to do on this unit before I can be happy with it and mount it in the rack. I want to finish up some wiring inside, and then I'll paint the panel and get it properly relabeled so it looks like something proper. I guess the big thing I want to get done is rebuild the demodulator board. After redoing the UART boards after the big smoke there, I look at this thing and I just, oh man, it's just ugly. You should see what it looks like underneath. I'll spare you that torture. Just for your interest, this is what it looked like in the evening around here at the beginning of this month from all the forest fire smoke we were getting. It's a lot clearer now, but it was pretty brutal back then. So I hope you made it through all this. Once again, thanks for watching. 73's from Skip, Victor Echo 6, Bravo, Golf Tango.